Hello again, this is Jeff Scott. For the last two lectures, I've talked with you about the Microsoft SDL Starter Developer Starter Kit, and I've gone over the Secure Design Principles, which is a level 100, and the Secure Implementation Principles, which is also a level 100. Now what I'm going to do is go over the third thing on security here, and that's the Secure Verification Principles, as you can see, also a level 100. So we're going to take it from the beginning. Again, we'll talk a little bit about, I don't know if it pays to keep going over this and talking about every single thing that's in here and all the phases, because we've talked about them in a couple of the lectures previously. So what I'd like to do instead is to come up here and take a look at the verification overview that we see right here. So in this particular set of PowerPoints, we're going to go over functional testing versus security testing, the security development lifecycle verification phase testing techniques, the security development lifecycle verification phase automation, and how to handle security bugs. So again, the key here is on the SDL verification phase topics. All right, to start with, let's talk about how security testing is different and distinct from functional testing. Functional testers evaluate to what extent an implemented app adheres to its original design. In other words, how closely do the two match? Essentially, the question that they ask is, does the application do what it was intended to do? In order to figure out whether or not that's the case, they develop and execute test cases to verify whether or not the app does indeed do what it was intended to do. If the functionality is not specified in an application's design, the functional testers will not test for that particular functionality. On the other hand, security testers fulfill a different and often more difficult and complex role. Their role, or these testers, evaluate to what extent an implemented application adheres to its original design, but their focus is solely on the security features of the app. So they're asking the question, how well were the security features implemented, if they were at all, and which ones, if any, are missing? In addition to the emphasis they put on evaluating the completeness of security features, security testers must also evaluate any unintended functionality of an app. Why? Because this could lead to misuse. So security testers evaluate the ability of a malicious user to exploit any extra or unintentional functionality. Sometimes this is known as negative testing. And as you can see here, when we talk about functional testing versus secure testing, there's some people who have argued that functional testing should incorporate security testing considerations. All right, and the operative word there is should. In an ideal world, test plans would include both positive types of tests, the functional kind to make sure that the system is doing what it's designed to do, and negative or security type tests. But that's not typically the way that it's done. So as we look at these two circles that you see right here, let's focus our attention on what's on this slide. The circle on the left corresponds to the intended functionality of the application. This is the functionality that the original designers had envisioned for the app. The circle on the right corresponds to the actual implemented functionality of the application. This is the functionality that's implemented through source code, etc. Traditional function testing tends to focus on this first section. In other words, the emphasis is basically on intended functionality without any regard to evaluating any extent of actual functionality. Functional testing conducted here can also address a subset of security testing. and that subset focuses on the insufficiency of security controls. As an example, insufficient authentication or authorization controls. However, specifying security controls in app design is pretty rare. The section that you see in the center, in other words, that's the overlap or the intersection, that corresponds to the application functionality that has been specified in the app designs and has also been implemented in the application. Functional testing that's conducted on this section can also address a subset of security testing. As an example, an evaluation of how well authentication controls were implemented. But however, functional testing performed in this section rarely identifies these types of issues. And then lastly, the final section that we have here corresponds to testing application functionality that was not intended by the application designers, but was inadvertently implemented in the actual application code. As an example, can include security implementation issues, things like buffer overflows and integer arithmetic errors that we've touched on previously. Implementation issues like these can have very serious security ramifications. We've talked about that before. Some security testing tips. In order to be an effective security tester, you need to think like a malicious user. In other words, think like the attacker. The first and only rule of security testing is there are no rules. Malicious users wouldn't try to do that? Well, yes, you know they will. All right. Sometimes you'll learn of application development teams who have analyzed the security issue and conclude that malicious users would not try to do that. But again, those are famous last words. Quite often they will. The only valid assumption that you can make about malicious users is that eventually they will attack your application. All right. Malicious users don't have to play the game by your rules. They make their own rules. They commonly bypass client components entirely and use raw protocol commands, scripts, attack tools, whatever is available for them. And basically, in these types of scenarios, any protection implemented within client components will be bypassed. All right. Finally, security testers must be aware of the capabilities of more sophisticated malicious users. Your app must be able to continue to operate securely when its dependencies fail or they've been compromised. So looking here, we see the SDL verification phase testing techniques. So it's time now to cover some prevalent security testing techniques employed during the SDL verification phase. All right, this phase includes, but is not limited to, fuzz testing, penetration testing, runtime verification, and code review. Each one of these different types of testing techniques has their own pros and cons. All right, let's start with fuzz testing. A majority of application vulnerabilities exist today due to developers failing to validate inputs. We've talked about this in several other lessons. Fuzzing is a testing methodology that can help you identify security issues due to inputs not being properly validated. Fuzz testing is a core testing technique in the SDL verification phase. There are several different approaches to fuzz testing. The two most common are known as smart fuzzing and dumb fuzzing. Smart fuzzing examines valid inputs into an app and then varies those inputs to create invalid inputs. Each of the invalid inputs is then input into the app being tested, and the app's behavior to those inputs is observed by a security tester. For example, if you had a credit card number that had 16 digits on it, all right, and it was supposed to be 16 numbers, you could try putting a mix of numbers and letters, or put more than 16 or less than 16 numbers. Dumb fuzzing is similar to smart fuzzing, except that the invalid input using this approach are created randomly rather than in a targeted and deliberative type of fashion. Fuzz testing, like any other type of security testing techniques, has its pros and cons. A big strength of fuzz testing is that the types of security code weaknesses it identifies are usually severe in nature. Things like buffer overflows, integer arithmetic errors, and SQL injection. One of the cons of fuzz testing is in order to identify security code weaknesses, the app needs to crash or error out due to invalid input. This means that any vulnerability that does result from a crash or error typically cannot be found in fuzz testing. So how do you fuzz test? All right, as you can see here, we've got the general approach. So the first thing you want to do is identify all of the entry points into the application. Secondly, you want to determine the valid inputs that each application entry point is expecting and create a set of valid inputs. Third, you want to modify the valid inputs created in step 2 to create invalid inputs. The final step is to feed these invalid inputs into the application and observe how it responds. If it crashes or raises an exception or causes some unexpected error, then a potential security code issue has been identified. The amount of invalid inputs used in fuzz testing, be it smart or dumb testing, can grow to be very large. Sometimes, literally, you can have hundreds of thousands of different kinds of inputs if you're trying to test everything. So it's recommended that in the SDL, that fuzzing tools be used to develop to conduct fuzz testing. Penetration or pen testing. Pen testing simulates an actual attack against an app and measures the app's ability to withstand said attack. Pen testing uses a number of manual techniques and automated tools to both test and exploit potential vulnerabilities in the app. When pen testing can be useful to understand the security posture of an app, but it's important to also understand that the results of pen tests are only relevant to the state of the app at the time of the test. In other words, what this means is that if the application changes or is re-engineered in any way, the results of the pen test may no longer be applicable and you may have to retest. You might be asking yourself right here, what's the difference between pen testing and fuzz testing? The goals of each one are similar. In fact, they may even overlap. Both may be used to analyze and improve the security posture of an app, but it's how each of these techniques arrive at the results, and that's where the difference is best realized. Automated tools use a set of checks and hard-coded methodologies to discover vulnerabilities. Pen testing uses the ingenuity of the pen tester. The human element here allows the pen tester to go beyond the simple discovery of vulnerabilities and yields the ability to connect vulnerabilities together to show possibly very damaging types of scenarios. Runtime verification. These types of testing techniques are used to simulate error conditions when an application is operational. The goal here is to observe how the app behaves under these conditions and detect any security code issues that may exist. Tools are often used for this in runtime verification. One of the key tools in the SDL is Microsoft's App Verifier, which will be discussed a little later. But briefly, it's a tool used to simulate runtime error conditions that would be difficult to create under normal testing situations. Code review involves the manual line-by-line review of the app's source code to identify common code weaknesses that a malicious user could potentially use to attack the app. Code reviews involve a considerable amount of effort and should ideally be conducted for high priority code. Code review is a very effective security testing technique. With code review, testers can clearly see what the app does, and they can focus their efforts on areas of code that are most likely to be attacked. But there is one negative aspect of the code review process. It can be very labor intensive and time consuming. Many apps today easily exceed hundreds of thousands of lines of code. So as such, the likelihood of a code reviewer missing something can be high. All right, but Microsoft has developed several code review tools used in the SDL that are available for download to assist its customers. We'll talk about some of those in a bit. It's important to note that any one of these tools in their own right is probably insufficient to endure, or to ensure, I should say, that an app is free from vulnerabilities. In other words, that it is really secure. In fact, there's no tool for Microsoft or any other company that can provide this type of assurance. Each tool has its own strengths and weaknesses, and that's one of the reasons Microsoft does not rely on any one testing tool or technique alone, but uses a combination of different types of tools. When you look on the left-hand side here, the first category of testing tools is static source code and analysis tools. These are tools that can scan the app's source code and alert testers to common detectable security vulnerabilities. You've got things like Microsoft's Prefast, which is a static source code analysis tool that detects certain classes of C and C++ coding errors. Visual Studio Code Analysis. Microsoft has integrated the abilities of Prefast into certain versions of Visual Studio. Cross-site scripting detect tool. Microsoft has also developed a Visual Studio plugin that may be used to analyze the .NET Framework applications for cross-site scripting type of issues. Finally, we've got Microsoft Source Code Analyzer for SQL injection in ASP code. This is a tool that Microsoft released to help developers identify certain SQL injection weaknesses in their ASP.NET code. It's a downloadable tool. Binary analysis tools, like static code analysis tools, can evaluate an app for common security implementation weaknesses. But instead of examining the source code, these tools examine the compiled binary of the app. So you can see we've got a couple shown here. Microsoft FXCOP, which is a binary analysis tool that examines the compiled .NET Framework assemblies for common coding weaknesses. Plus, you've got Microsoft Visual Studio Code Analysis, their Analyze tool. Microsoft has integrated the abilities of FXCOP into certain versions of their Visual Studio. Developers can use, and testers can use this feature to go through and analyze the Analyze switch to help identify common security code weaknesses in their app. Finally, we talk a little bit about some runtime analysis tools. These can be used to help assist testers in evaluating an application while it's operational. First, you see HTTP Fiddler. This is an HTTP proxy which testers can use to analyze request and response data to a web-based app. Next is Microsoft Windows sysinternals tools. These are a collection of tools that can be used to examine apps while running on the Windows operating system. Next, you see Microsoft App Verifier. App Verifier can be used to identify security issues related to heap overruns in unmanaged code. Following that, we've got Microsoft Visual Studio Analysis tools. Several runtime analysis tools like App Identifier are bundled within Visual Studio. Next is the Microsoft IE Developer Toolbar. Internet Explorer, or IE, the IE team has published a toolbar useful for debugging and analyzing web-based apps. And that tool can be downloaded. Microsoft SDL book fuzzing tools. The SDL book companion has a CD with some simple fuzzing tools in it. It's unfortunate for me, but as far as that goes, because I've got the book. I bought the Microsoft Secure Development Lifecycle book, but I bought it used, and the copy I bought did not have the CD in it. Handling security vulnerabilities. The SDL provides guidance regarding on how to respond to risks like these. Specifically, the SDL verification phase defines how app security issues should be handled through the creation of what's called a security bug bar. A bug bar defines beforehand how application security vulnerabilities will be rated, how they'll be filed, and how they'll be fixed. All right, and it can account for several different threats, such as the ones you see here. Elevation of privilege, which refers to the ability of a malicious user to execute arbitrary code to obtain more access privileges than he, she, or they were intended. Denial of service, which is the ability of a malicious user to deny legitimate users access to the app. Targeted information disclosure, which refers to the ability of a malicious user to locate and read information from anywhere on the system that the app is running on. Spoofing, which is the ability of a malicious user to impersonate another user or resource of an app or operating system. And then finally, tampering, which is the ability of a malicious user to permanently modify any user data or data used making trust decisions. So you can see we've got some different areas in here, some different severity ratings. All right. And they go from highest, which is Sev 1, to lowest, which is defense in depth. Now the highest is a number 1 there, and you'll notice elevation of privilege, because if you can elevate privilege where an anonymous user can act, for example, as an admin, that's about as insecure as you can make it be. So, in conclusion, this particular unit discussed the SDL secure verification principles. We looked at a high-level overview of the SDL and the role that it fulfills in the testing stage of an app software development lifecycle. We talked about several security testing tips, techniques, and tools. And we concluded by providing an overview of how SDL categorizes app security issues through the use of a security bug bar. You've already seen this, and these, and this, and this. Notice Microsoft also has a book out that's called Hunting Security Bugs. And that's pretty much it for this particular lesson.